Okay, this is quiz 4 for Math 12 Pre-Calculus. So the first question asks us to find an equation of the form y equals a sine bx plus c for the sinusoidal function shown below. Okay, so I've drawn this shape. It passes through the point 0, 0 and the point negative, this, I keep doing these backwards. This should be pi over 4. Negative 5/3. Okay, so x value is pi over 4, y value is negative 5/3. Okay, so the first question asks us, what is this function's amplitude? Okay, the amplitude is the distance that this function gets away from the x-axis. So clearly this is going to be 5/3, right? So this point is at the bottom of this, curve, and it tells us that the farthest this function is going to get away from the x-axis is negative 5/3. Okay, so the function's amplitude is 5/3. Now a is going to be either negative 5/3 or 5/3. We have to decide whether this is going to be a positive sign or a negative sign, whether this is a reflection of sign about the x-axis or not. Now, since a normal sign looks something like this, it passes upwards through 0, 0 and continues around, we know that this is negative, right? So we're going down through the point 0, 0, so we're going to reflect it about the x-axis. So a is negative 5/3. Now the function's period is how long it takes for one complete cycle of sine. Okay, so we start out, I'm going to start at the point 0, 0 and find out when I get back to the point 0, 0 and I'm going downwards. So here I go through, at this point I'm at 0, but I'm going upwards, so I haven't finished my cycle yet. So here I'm going down, up, down. So this is where the period ends. Okay, so this is the distance we're looking for, from this point 0, 0 to whatever this point is, where y is equal to 0. So notice when I get to this point, I restart this shape again. So I go down, up, and around. Okay, so I'll do this exact shape again. Okay, so the function's period is this distance. We have to figure out what this distance is. Now, I've given you that this distance from here to here is pi over 4. Now the good thing about sine and cosine is that they are nicely symmetric, right? So if this distance is pi over 4, then this distance from right here to this point is pi over 4. And then this distance to here has to be pi over 4, and this distance has to be pi over 4. So in other words, this pi over 4 distance is just 1/4 of the entire period. Okay, so pi over 4 is 1/4 of the period. So the period is pi. Okay, now this is not b. b does not equal pi. Okay, b, what we know is that the period is equal to 2 pi over b. Okay, we know what the period is. Pi is equal to 2 pi over b, so we can solve for b. Clearly this tells us b is equal to 2. Okay, so that's my value for b. Okay, now the function's phase or horizontal shift, well, sine passes through the point 0, 0, and our function passes through the point 0, 0, so we haven't been shifted. So the phase shift is 0. Now the phase shift, what's called PS, is equal to c over b. Now here we know 0 is equal to c over b is 2, which tells us that c is equal to 0. Okay, so now all we have to do is write down the equation of our sinusoidal function. So y equals a, which is negative 5/3, sine of bx, that's 2x plus c, which is 0. So the function's equation is y equals negative 5/3 sine of 2x. Okay. Problem 2 asks us to find the tangent of 75 degrees. The hint here is that 75 degrees is pi over 4 plus pi over 6. Okay, so the tangent of two angles added, s plus t, is the tangent of s plus the tangent of t all over 1 minus the tangent of s times the tangent of t. Okay, so tangent of 75 degrees is the tangent of, I can write this as pi over 4 and pi over 6, or I can write it in degrees. I'm going to write it in degrees. So this is the tangent of 45 degrees plus 30 degrees. Okay, so using this formula, I get that this is the tangent of 45 degrees plus the tangent of the second angle, 30 degrees, over 1 minus tangent of the first angle, 45 degrees, times tangent of the second angle, 30 degrees. Okay. What is tangent of 45 degrees? Well, that's sine of 45 degrees over cosine of 45 degrees. Okay. Now, sine of 45 degrees is root 2 over 2, and cosine of 45 degrees is root 2 over 2. So tangent of 45 degrees is just 1. Tangent of 30 degrees is sine of 30 degrees over cosine of 30 degrees. Now, sine of 30 degrees is 1/2. Cosine of 30 degrees is root 3 over 2. So this is 1/2 times 2 over root 3, which is 1 over root 3, which we can rationalize the denominator and find out that it's root 3 over 3. Okay, so now going back and using this formula, we get that this is the tangent of 45 degrees, which is 1, plus the tangent of 30 degrees, which is root 3 over 3, over 1 minus the tangent of 45 degrees, which is 1, times the tangent of 30 degrees, which is root 3 over 3. Now doing a little simplification, I'm going to rewrite 1 as 3 over 3. So I got 3 over 3 plus root 3 over 3 all over 1 I'm going to write as 3 over 3 minus 1 times root 3 over 3 is just root 3 over 3. Okay, simplifying the fractions on top and bottom, I get 3 plus root 3 over 3 all over 3 minus root 3 over 3. Now with the division of fractions, we invert and multiply. So 3 plus root 3 over 3 times this fraction inverted, which is 3 over 3 minus root 3. The 3's cancel, and we end up with 3 plus root 3 over 3 minus root 3. And that's our answer. Now notice you could have stopped at this point. I just wanted to simplify it a little. Okay, problem 3, which was for extra credit, asks us to simplify sine of 2 theta over sine of theta. Now here we have to remember the double angle formula. Sine of 2 theta is equal to 2 sine of theta cosine of theta. Okay, so then sine of 2 theta over sine of theta is equal to sine of 2 theta, what's on top is just 2 sine theta cosine theta over sine of theta. Now the sine of theta on the top and bottom cancel, and we're left with only 2 cosine theta. That's our answer.